In this section, we'll cover the basics of a wet fire sprinkler system and examine each component of wet risers, including their components. Understanding the essential characteristics of each type of system equips you with the knowledge needed to operate it effectively and stay informed about its functionality. More information on the types of fire sprinklers are defined in Chapter 3. There, our special rules for the different system types are in Chapter 8. When considering a fire sprinkler system, many opt for a wet system because it offers immediate protection by having water constantly available for quick activation during a fire. Its straightforward design and reliable operation make it a cost-effective choice with minimal maintenance needs. Wet systems are proven to effectively suppress fires, and they often lead to reduced insurance premiums due to their effectiveness in mitigating damage. A wet fire sprinkler system is one of the most common types of fire protection systems used in buildings. It consists of a network of pipes filled with pressurized water that is always ready to flow when a sprinkler head is activated by heat. Water vault, other known as a water pit. These vaults protect critical equipment from weather, tampering, and freezing, while providing easy access for inspections and maintenance. They are usually located at the property line where the city water supply connects to the building's fire sprinkler system. The water supply is the source that provides the necessary water flow and pressure to operate a fire sprinkler system. Common water supplies include city water mains, most common, on-site storage tanks, private reservoirs or ponds, fire pumps to boost pressure if needed. The water supply must be reliable, capable of delivering enough volume and pressure, and meet NFPA 13 standards to ensure the system can control or extinguish a fire when activated. Flushing underground before install the backflow according to NFPA 13. Underground piping, from the water supply to the system riser, and lead-in connections to the system riser, including all hydrants, shall be completely flushed before connection is made to downstream fire protection system piping. Underground piping going past slab should not exceed 24 inches. See more in Section 6.1.4. All piping to the BFV backflow preventer needs to be anti-corrosive piping. Any bypass on the BFV like this, C300 for the water meter, also have its own double check valve. Make sure when installing you put the direction of backflow right. If not, when you fill up it, well, stop at backflow. The fire sprinkler control valve is the main shutoff valve for a sprinkler system. It controls the flow of water from the water supply into the system's piping. It's usually a post indicator valve, PIV, OS and Y gate valve, or butterfly valve. Must be open for the system to work. Clearly marked and easily accessible for firefighters and inspectors. Often located in a water vault, hodge chop pit, or inside a riser room. By closing this valve, the entire sprinkler system can be isolated for maintenance or emergencies. Indicating control valves can be found in 7.6 and 16.9.3. The valves have to be listed and approved by a AHJ. Now let us move forward into the valves themselves. An OS and Y valve, also known as an outside screw and yoke valve, is a type of valve commonly used in various industries for flow control applications. The term OS and Y refers to the design features of the valve, where the stem is located on the outside of the valve body and operates through a yoke mechanism. This design allows for easy identification and monitoring of the valve position, providing visual indication of whether the valve is open or closed. The OS and Y valve is widely recognized for its reliability, durability, and safety features, making it a preferred choice in critical applications such as fire protection systems and water distribution networks. The OS and Y tamper switch is designed to activate when the valve stem is moved or tampered with. It is usually set on a notch position and sends a notification if it is disturbed. If it is improperly set or adjusted, the switch may trigger repeatedly as it moves along the stem threads. Post-indicator valves are generally used to control the flow of water to a sprinkler system, hydrant, or another device with underground piping. Since the first post-indicator valve was installed in 1974, this equipment has been a mainstay of fire protection applications where responding firefighters need a clear indication of whether an out-of-sight valve is open or closed. The valve assembly also serves as an easy way to stop the flow of water from the water supply main during emergencies or routine maintenance. A wall post indicator shows the operator if the non-rising stem gate valve it's attached to is in the open or shut position, and provides a means to operate that same non-rising stem gate valve when it's behind a wall. Butterfly valves are among the family of quarter-turn valves and work very similar to ball valves. The butterfly is a disc connected to a rod. It closes when the rod rotates the disc by a quarter turn to a position perpendicular to the flow direction. When the valve opens, the disc is rotated back to allow the flow. A ball with a hole through the middle is installed within the body. If the hole is in line with the flow, the valve is said to be in the open position, and there is little resistance to flow. If the hole is rotated 90 degrees and is perpendicular to the flow direction, the valve said to be in the closed position, and there is no flow. Main control valve is to control the flow of water into the fire sprinkler system. It can be opened or closed manually to isolate a sprinkler system. There are multiple types of valves you can use as a main control valve. The ones being used in this figure is called a butterfly valve. If it's only one system being fed, it normally just use the valves on the BFV, backflow preventer, as the main control valves. Identification of valves. If there are multiple systems being fed, there shall be signage saying what is each system is feeding to. Every control valve shall have a indicating showing if it's open and closed. The identification sign shall be secured with corrosion-resistant wire, chain, or other approved means. Valves close in not less than 5 seconds to prevent a water hammer in the fire sprinkler system. The minimum valve closure time of 5 seconds reduces the possibility of causing a water hammer in a system where water is flowing. Water hammer can instantaneously raise the pressure of the system well beyond the design pressure, which can result in damage to components or leakage. Water hammer, which sounds like knocking in the pipes, can be caused by suddenly stopping the flow of water, causing a pressure surge. Every valve that have an impact on an active system shall have a form of tamper on it notifying to fire panel if the valve is being tampered with. This is very important. According to NFPA, automatic sprinkler systems have a 96% success rate, with over 80% of the failure it is due to a closed valve. This prevent that. Major control and isolation valves in traditional fire sprinkler systems are typically large gate valves of the outside screw and yoke, OS and Y type, sometimes called rising stem valves. The state, open or closed, of this type of valve can be determined at a glance, and specialized locks and alarm sensors may be attached to restrict and monitor the settings of these valves, which are critical to overall building safety. Newer systems may use butterfly valves instead of some or all possible OS and Y valves. These valves are used to satisfy regulations which require indicating valve state can be quickly determined and monitored, and that they cannot close in less than 5 seconds to avoid water hammer. Now let us move on to the check valve. 3.3.28 check valve. A valve that allows flow in one direction only. And sprinkler system check valve is useful in many situations. Prevent water to go back and go to other systems. Prevent pressure lost back into the water feed. Check valves can be required to prevent false water flow signals on floors where sprinklers have not activated. For example, floor systems interconnected to 2 supply risers. Alarm check valve is similar like a dry valve with the high pressure switch. As water flows through, it goes through the water gong line, chachas purge line, depending on the model. Looking at the main drain now, is a drain that drains most is not all of the fire sprinkler system. The intermediate pipe between the 2 check valves shall be arranged to drain. Odd drain between the system check valves and the backflow. Like in this video, the drain is on the 6-inch elbow under the FDC. Main drains have a minimal size for the size of riser you are working on. Main drain drains all, if not most, of the system. These are the 2 most common types of valves you will see as main drain. Ball valve, angel valve. Drains with riser size of 2 inches and smaller shall have a drain size of 3/4 or larger. It would be common to have it at 1 inch. 2.5 inches through 3.5 inches should have a drain size of 1 1/4 or larger, and all risers that is 4 inches and larger shall have a drain size of 2 and larger. Where subject to freezing, a minimum 4 feet of exposed drain pipe shall be in a heated area between the drain valve and the exterior wall when drain piping extends through the wall to the outside. After a new system is installed, a main drain test needs to be conducted. Why are main drain tests conducted? The common practice known as a 2-inch 50mm main drain test typically involves fully opening the 2-inch 50mm main drain until the pressure stabilizes. These tests are documented to identify any potential degradation of water supplies or to uncover closed valves within the overall water supply system. For newly installed systems, conducting a 2-inch 50mm drain test requires establishing a baseline measurement during the initial approval phase of acceptance testing. Additional guidance on conducting these tests can be found in NFPA 25. Why are main drain tests conducted? The common practice known as a 2-inch 50mm main drain test typically involves fully opening the 2-inch 50mm main drain until the pressure stabilizes. These tests are documented to identify any potential degradation of water supplies or to uncover closed valves within the overall water supply system. For newly installed systems, conducting a 2-inch 50mm drain test requires establishing a baseline measurement during the initial approval phase of acceptance testing. Additional guidance on conducting these tests can be found in NFPA 25. A fire department connection, FDC, is a critical component of fire protection systems and is designed to provide a means for firefighters to connect their hoses to the building's fire protection system. FDCs are typically installed on the exterior of buildings and are crucial for quick and efficient fire response. A fire department connection, FDC, were traditionally equipped with threaded sizes of 2.5 inches for the 2.5-inch hoses for the fire department pumper. Some fire department connections are now equipped with non-threaded connections in inlet sizes of 4 inches or even 5 inches. Fire department connection. A connection thorough which the fire department can pump supplemental water into the sprinkler system, standpipe, or other water-based fire protection systems, furnishing water for fire extinguishment to supplement existing water supplies. The purpose of the fire department connection is to supplement the water supply but not necessarily provide the entire sprinkler system demand. Fire department connections are not intended to deliver a specific volume of water. Where local fire department connections do not conform to NFPA 1963, the authority having jurisdiction shall be permitted to designate the connection to be used. The use of threadless couplings shall be permitted where required by the authority having jurisdiction and where listed for such use. 6.7.1.3. A single outlet fire department connection shall be acceptable where piped to a 3-inch or smaller riser. Fire department connections shall be equipped with approved plugs or caps, properly secured and arranged for easy removal by fire departments. Each source of water supply, with the exception of the fire department connection, is to be equipped with an indicating control valve to isolate each source. 16.12.2. The following systems shall not require a fire department connection. Buildings located in remote areas that are inaccessible for fire department support. Large capacity deluge systems exceeding the pumping capacity of the fire department. Single-story buildings no exceeding 2,000 square feet in area. Underground piping, from the water supply to the system riser, and lead-in connections to the system riser, including all hydrants, shall be completely flushed before connection is made to downstream fire protection system piping. Fire department connections. The fire department connection should be located not less than 18 inches and not more than 4 feet above the level of the adjacent grade or access level. The following systems shall not require a fire department connection. Buildings located in remote areas that are inaccessible for fire department support. Large capacity deluge systems exceeding the pumping capacity of the fire department. Single-story buildings not exceeding 2,000 square feet in area. Fire department connections shall be located at the nearest point of fire department apparatus accessibility or at a location approved by the authority having jurisdiction. The fire department connection shall be permitted to be connected to main piping on the wet pipe or deluge system it serves. For multiple systems, the fire department connection shall be connected between the supply control valves and the system control valves. The fire department connection shall be permitted to be connected to main piping on the wet pipe or deluge system it serves. For multiple systems, the fire department connection shall be connected between the supply control valves and the system control valves. If the fire department connection does not supply the entire system, a sign or indicator is required to indicate which part of the building it services. A local fire alarm on a fire riser, like a water flow switch or water gong bell, activates when water begins flowing through the sprinkler system. The flow switch detects movement and sends a signal to the alarm panel, while the water gong bell rings loudly using water pressure, alerting people nearby that sprinklers have been triggered. Both are key for fast local response during a fire. Wet pipe systems. The alarm apparatus for a wet pipe system shall consist of a listed alarm check valve or other listed water flow detection alarm device with the necessary attachments required to give an alarm. Wet sprinkler systems have water on both sides of the risers, letting water out as soon as a fire sprinkler head goes off. Wet sprinkler systems are the most common and the simplest systems to operate. Paddle-type water flow alarm indicators shall be installed in wet systems only. Alarm check valve with both a pressure switch and a water motor-operated device with a retarding chamber, along with the control valve. Feed to water gong, retarding chamber, pressure switch, control valve. Outdoor water, motor-operated or electrically operated bells shall be weatherproofed and guarded. All piping to water motor-operated devices shall be galvanized steel, brass, copper, or other approved metallic corrosion-resistant material of not less than 3/4 inch nominal pipe size. Series pressure-actuated switches are designed for the detection of a water flow condition in automatic fire sprinkler systems of particular designs, such as wet pipe systems with alarm check valves, dry pipe, pre-action, or deluge valves. The PS10 is also suitable to provide a low-pressure supervisory signal, adjustable between 4 and 15 psi. The retarding chamber is a simple reservoir that collects the excess water from the surge. If the surge does not exceed the capacity of the reservoir, once the surge stops, the water will drain from the retarding chamber and no water flow alarm is transmitted. At least one pressure gauge is required in each system riser. When any type of check valve is used at the connection to the water supply, 2 gauges are required, one on the supply side of the check valve and one on the system side. If a backflow preventer is used as the system control and check valve, a gauge is required on the supply side of the backflow device as well as the system side. The surge of water that occurs when the valve trips can seriously damage the device. Paddle-type water flow devices are also permitted to be installed on wet systems that supply auxiliary dry pipe and/or pre-action systems. Where a retarding chamber is used in connection with an alarm valve, the strainer shall be located at the outlet of the retarding chamber, unless the regarding chamber is provided with an approved internal strainer in its outlet. In high-rise buildings, risers are typically installed within stairwells. The riser manifolds branch off from a main feed, and the main drains are connected to discharge outside the building.